Hey everyone, so welcome to this video, and in this video we are going to discuss one more problem on graph data structure, right? So the problem is pretty simple and I'm sure you'll not find any difficulty in understanding this problem as well as solving this problem, okay? So the question is, you are given a graph. Let's say this is a graph. So in this graph, let's say we have 4 nodes, right? 0, 1, 2 and 3, and in that graph you need to find the number of components. So what do you mean by components? So let's say this is case number 1, and in second case let's see this graph. So let me rub this. Okay, so this is case number 2, and here in case number 2 this is a graph. So 3 nodes are connected with each other, but the 4th one is not connected with the main graph. Okay, so this is case number 2, and here we have 2 components. This is component number 1 and this is component number 2. So you can see the difference. So you just need to return the number of components in a given graph. Okay, so here the answer should be 2, and in this case the answer should be 1. Let's see the third case. So this is one graph. So 3 nodes, and these 2 nodes are connected, and we have one single node. Okay, so this is actually a single graph but with multiple components. So here the output should be 3. So this is the problem statement. So we just need to return the number of components in a given graph, right? So if you are familiar with DFS traversal, okay, DFS traversal, then in case of DFS traversal, let's say if I run DFS traversal on this graph, so it will visit all of these nodes, all of the connected nodes, right, in a single go. But let's say if I run DFS traversal on this graph, so let's say this is node number 0, and if I take this node as a root node and run DFS traversal on this graph, so it will visit its connected nodes only. So it will visit 0, then 1, and then 2. That's it. Okay, it will not consider this component as a connected component. So but using DFS we can solve this problem. Okay, so what we can do, we can run a for loop, and inside this for loop we can run the DFS function. Okay, and in the for loop we can write this condition like you should visit all these nodes. Okay, so okay, let's see this example. If I run DFS traversal on this graph, okay, this smaller component, so it will visit only these 2 nodes. Okay, it will not consider all these nodes. Okay, all these nodes. So but let's say if I run for loop and if I program this for loop in such a way that it should visit all of these nodes, then we can find the number of components in a given graph. Okay, so let's see how we can implement this algorithm. So here this is the basic function for a graph, and here I'll create another function, that is DFS. So void DFS, and I'll pass the root node. Let's say it is u, and the first thing that I'll do is I'll mark this node as visited. Okay, and then we just need to visit all of these nodes. Okay, so for that I'll use this for loop, auto it g of u, and inside this for loop we need to check whether the node is visited or not. So if it is not visited, so we'll call this DFS function again recursively. Okay, so this is the basic DFS function, and in main we just need to use another for loop, right, int I is equal to 0, I smaller than. Okay, so here we need to write the number of nodes. Okay, because we just need to visit all of these nodes. So here in this case the number of nodes are 1, 2, 3, 4, 5, 6. Okay, so here we need to write the number of nodes. So the number of nodes is represented by m. So I'll write m here, and I++. Now we'll check if the visited node, if the node is visited, okay, or not visited. We will call the DFS function, and I'll create a counter here and cnt. Okay, this is a counter variable, so I will initialize this counter. Okay, and at the end we just need to print this count variable. So this count variable will count all of these components. Let's say if I run DFS traversal on this component. Okay, so if I pass this node as a root node in the DFS function, so it will visit all of these nodes. Okay, node 1, 0, 1 and 2, and the visited of 0, 1 and 2 matrix, let's say this is a visited matrix. Okay, so for 0, 1 and 2 it will be 1, 1, 1. Okay, but for 3, 4 and 5 it will not be 1. Okay, so again we'll come inside this for loop, and again inside this for loop. So again DFS function will be called, and all of these nodes will be marked as visited. Okay, so this is the basic idea. Now let's run this code. So first we need to compile this. So it is compiled successfully. Now if I run this, let's create a graph here. So 0, this is node number 2 and this is node number 3. Okay, this is 1 and this is 2, and let's create one more component here, that is 3. Okay, now if I run this, so the first thing that we need to do is we need to write the number of edges. So here we have only 2 edges, and then we need to write the number of nodes. So 1, 2, 3 and 4 nodes. So the first edge is in between 0 and 1, and the second edge is in between 1 and 2. So here you can see that the output is 2. It means that we have 2 components in this graph. Now let's create another component. Let's say we have 2 extra nodes. This is node number 4 and this is node number 5, right? Now let's implement this. So if I run this again, and here we have 3 edges now and 6 nodes. The first, 6 nodes, yeah. So the first edge is in between 0 and 1, then we have 1 and 2, and then we have 4 and 5. So here you can see that the output is 3. It means that we have 3 components in this graph. So this is how you can find the number of components in a particular graph. Okay, so that's it for this video. Thank you.